Hi boys and girls. So we're going to start off today kind of just reviewing a little bit what we did yesterday with box plots. So I've drawn two box plots on the board here. Okay, our top box plot and our second box plot. And I want for you to think to yourself what it is that we learned about box plots yesterday. Box plots are a graph that show us visually how close together our data sets are or how far apart they are. Okay, so we talked about in lesson 13.1, we talked about patterns in data and gaps and things like that, clusters of data. Okay, so looking at both of these box plots, this top box plot, you can see that everything is kind of evenly spaced out. Remember, each of these segments contains 25% of the data. Okay, and so this is what we would say, this box plot is pretty symmetrical, right? Because each of these segments, is about the same. Okay, this box plot on the other hand, okay, there's 3 segments right here, which means that 3/4 of our data is just scrunched together, really close together. And then we have this super long whisker with this highest data value clear out here. Okay, so I want you to think to yourself, when I have a data value that is this far away from the other data values, then what does that mean? Right? What do we call that when I have a data value that's super far away, which is what's causing this super long whisker? Okay, remember that's called an outlier. We talked about it in chapter 12. Okay, this is kind of like me and Mrs. Burt. We were way older than you, right? Okay, so we would say that this graph is showing us there's a lot of variability in our data. Okay, because this graph doesn't have a lot of symmetry. This one is more evenly spaced out, which shows us that our data values are a little bit more consistent. Okay, so today in lesson 13.3, we're going to talk about another way that we can tell how close together our data values are or how far apart they are. Okay, so I've written some data over here on the board. Okay, we have Team A and Team B. And we'll say, boys and girls, this is maybe how many points a team scored in their softball game. Okay, so I want you to look at those data values. Team A had 3, 3, 4, 5, and 5. Okay, Team B had 0, 1, 4, 7, and 8. Okay, so I want you to look at both of those teams and decide for yourself kind of what those data values look like. Are they super spread out? Are they pretty close together? What do you think? One team is quite different than the other team. Okay, so hopefully as you looked at that, you realized that Team B has data values that are a lot more spread out. I mean, sometimes they got a 0, sometimes they scored 8. Okay, not as consistent. Okay. On the other hand, when we look at Team A, all of their data values are pretty close together. Okay, now, one of the interesting things about this, boys and girls, is one way that we've talked about finding or giving information about a data set is we've said that we can use the mean, the fair amount. Okay, and we find the mean by adding all of our numbers together and then dividing by how many there are. Okay, would it surprise you to know, boys and girls, that both of these data sets, they both have a mean of 4. Okay, so even though as we look at those data sets, they're a lot different from each other, the mean of both of those is 4. So sometimes using the mean doesn't really give us the full picture. And so we're going to talk about another thing that we can use that's called the mean absolute deviation. And that helps us to understand our data set a little bit more. It helps us to understand how close are our values together and how far apart they are. Okay, so if you get your book and you open up to lesson 13.3, you're going to see, boys and girls, that these data sets came straight from the book. Okay, there's a little investigate lesson there, and what we've talked about here is what that lesson is. Okay, so we're going to turn the page and we're going to do some examples from lesson 13.3 now. Okay, boys and girls, so what we're going to learn about today is we're going to learn about how to find what's called the mean absolute deviation. And I know that sounds like a super scary word, okay? It's super scary to me, but it's also kind of a little bit funny too, because oftentimes when we're talking about mean absolute deviation, we see it abbreviated. And the abbreviation for it, boys and girls, kind of makes me laugh. Okay? The mean absolute deviation is not hard to find. Today, we're going to focus on how you find it, and then lessons that come up later we're going to learn more about why it's important and what it actually means. So remember in our investigate that we did with Team A and Team B, we were looking at data sets that had really close values, and then our Team B had values that were really spread apart. The interesting part about that was they both had the same mean. The mean absolute deviation is a way that we can know for sure if data values are spread out or if our data values are really scrunched together. And this right here, this example in our book, is a way that shows us that. Okay, and so that's why it says make connections, is this is showing us why it does that. Okay, it says the dot plot shows the ages of gymnasts registered for the school team. The mean of the ages is 10. And then it says find the mean absolute deviation of the data. Okay, now that word deviation, boys and girls, is similar to the word deviate. And to deviate means that you have kind of moved away from the plan. Okay, so when we're talking about mean absolute deviation, that's talking about how far away in an absolute, remember when we talked about absolute value? Absolute value is talking about how far away from 0. So when we say mean absolute deviation, that means how far away from the mean did you deviate? Did you go away? Okay, so our problem told us that the age of the gymnasts was 10, and each of these dots on this dot plot represents one of the gymnasts. So we have 4 gymnasts that are 8, a gymnast that is 9, 3 that are 10, 3 that are 12, and 1 that's 13. Okay, so that's what our dot plot shows. And we want to figure out how far away from 10 are all of these data values. So when we look at these dots, okay, we can see that 8 is 2 spaces away from 10. So this gymnast would be 2 years away. That one, that's 2, that's 2. Now we're talking about 1 space away. Okay, all of these gymnasts are 10, which means they're 0 spaces away. Okay, and now 12 gymnasts that are 12, those are each 2 away from 10. And this gymnast is 13, she's 3 away. Okay, so all of these numbers that we just wrote tell us how far away is this from the actual mean of 10. Okay, and we're going to calculate, boys and girls, on average, how far away are our ages. That's what mean absolute deviation is. So to find the mean, we're going to add each of our data values together, and then we're going to divide by how many data values we had, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So once we add all of those together, we're going to divide by 12. Okay, so we had 4 2s, 1 1, 3 0s, 3 2s, and 1 3. Now, one of the good things about doing mean absolute deviation is usually your data values aren't super spread out, and so it's easy to add in your head. Okay, so 2 plus 2 is 4, plus 2 is 6, 8, 9, 9, 9, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so that will be 18 divided by 12. Okay, 18 twelfths, boys and girls, that's 1 with 6 pieces left over, and we needed 12 to make a whole, and that is the same, 6 twelfths is the same as a half. So what that means is that on average, our data values were 1.5 away. Okay, so boys and girls, that's kind of pretty close. 1.5. So if we have a mean absolute deviation of 1.5, that tells us our data values are pretty close together. And when you look at it, that seems pretty true. I mean, we have this one gap in our data, if you want to call it a gap, but really it just means nobody was 11. Okay, but from 8 to 13, boys and girls, that's pretty close together. If we were talking about 8 to 30, that would be more spread out. Okay, and then our mean absolute deviation would be a lot higher than 1.5. Okay, remember, today that we're just focusing on how to find the mean absolute deviation. We're going to do one more example from our share and show, and then you can practice in your assignment. All right, so boys and girls, here we are on our share and show. I'm just going to do problem number 1. Okay, it says, find the mean absolute deviation for both data sets. Explain which data set is more spread out. Okay, now boys and girls, as you look at that, you can probably see which data set is more spread out. Okay, but I want you to see what that does to having a data set that's more spread out, what that does to the mean, or the mean absolute deviation. Remember, oftentimes it's abbreviated like this. Okay? Alright, so it says the number of laps Shauna swam on 5 different days. Okay, 5, 6, 6, 7, 5, 6, 6, 8, and 10. And then it tells me the mean is 7. So to find the mean absolute deviation, I'm going to figure out, okay, how far are each of our data values away from 7? I like to write it right under that data value. Okay, so how far away is 5 from 7? That's 2 spaces. 6 from 7, that's 1 space. 1 space. 8 from 7, that's 1 space away. And 10 from 7, that's 3 spaces away. Okay, so once I figured out how far away each of those data values is from the mean, I'm going to add those all together. 2 plus 1 plus 1 plus 1 plus 3. And then I'm going to divide by how many data values I have, which in this case is 5. Okay, 2, 3, 4, 5, 6, 7, 8. So that's 8/5, which if I simplify that fraction, boys and girls, that would be, let's see, that says we have 8 and we need 5 to make a whole, so we can make 1 whole one. We'll have 3 left over, and we needed 5. So the mean absolute deviation is 1 3/5, which that represents each of those data values is about 1 3/5 apart, less than 2. That means they're pretty close together. Okay? So, and looking at those, boys and girls, I mean 10 is a little bit more, but it's easy to see that those are pretty close together. Okay? It'll be interesting to see what the mean absolute deviation for these numbers are, because as I look at those, they're not super close together. Yet they still both have a mean of 7. Okay? So how far away is 7 from 1? That's 6 spaces and 4 spaces. 0 spaces. 4 spaces. 6 spaces. Ooh, that's kind of like a pattern. 6, 4, 0, 4, 6. What are those? What's that called? Palindrome, when it's forward and backwards the same. Okay, anyway, sorry. So to find the mean of those, we're going to add them all together. 6 plus 4 plus 0 plus 4 plus 6. And we're going to divide all of that by 5. Okay? So adding those all together, boys and girls, 6 plus 4, that's 10. Plus 0 plus 6 and 4, also 10. So 20 divided by 5, which is, it says we have 20 and it takes 5 to make a whole one. That's 4. Okay, so the mean absolute deviation in this example is 4, which means on average our data values were 4 away from each other. Okay, that shows a lot more variability. That shows our data values were more spread out instead of all scrunched together. Okay, so today we're practicing finding the mean absolute deviation. Okay, we got to figure out how far away each of our data values is from the mean. And then after we calculate the distance from the mean, we're going to add them all together and divide by the number of data values. Okay, if you need help, reach out to your teacher.